So now let's look at the basic concept behind non-maxima separation. So earlier we saw that when we predicted, we saw there are so many bounding boxes, which is overlapping, completely overlapping. So the idea behind non-maxima separation is to reduce the overlap and then get only as minimal as possible, minimal number of boxes as possible, so that it covers the maximum area. So what needs to be done is, from a conceptual perspective, is to reduce all these overlapping boxes, and that's what we do with non-maxima separation. So let's look at before we get into the function to eliminate these non-maxima separation, or let's look at the total number of boxes which we have. So the total number of predicted boxes is around 19. So we have to bring that down so as to reduce the overlap between all these boxes. So let's look at the function which does this. So this is maximum overlap, this is the function, and we take the input as the boxes, the bounding boxes, which has got the x1, y1, x2, y2 coordinates of the boxes. That's all those 19 boxes. That's the input. So first we convert that into a array, and then we initialize a list, empty list, to start collecting those boxes which has the minimal overlap between this. So the first concept, or first thing which we are going to do is, we're going to take the largest of these boxes, and then compare other boxes with the largest boxes. So that's the way we're going to proceed forward in this. Okay, so first we proceed with this iterative loop only if the length of boxes is more than one. That is, we have more than one bounding boxes inside this. So first we calculate, or we first first is to calculate the area of all the bounding boxes. Okay, so to find out which bounding boxes has the largest area. That's the first idea. So we get the x coordinate, y coordinate, x1, y1, the starting coordinates, xy coordinates, and the ending x and y coordinates of these boxes, and then we calculate the area. So if there are 19 boxes, we will have 19 areas here. 19 areas would be calculated here, and then we sort them, all those 19 areas, and then find the ID of the and this ID will give you all the boxes in a ascending order. So the last box would have the maximum area. Okay, and then we take the coordinate of the box with the largest area, which is, so the last one, which is represented by -1. So we take the starting x and y coordinates and ending x and y coordinates. So we know this is the largest area. So we add that largest area, the box with the largest area, in this list. So that's the first thing. Now next is to eliminate. So next step is to eliminate all those boxes, other boxes, which has the maximum overlap between. Because the idea is this, if both these boxes have maximum overlap, you are not getting any additional information. So we are eliminating all those boxes which has the maximum overlap into the remove list. Okay, so first of all, we are removing after we have selected the last one, which is the one with the largest area, we are putting that also in the remove list, because in the next cycle, because this is a continuous cycle, because once we take the one with the largest one, then progressively we go to the next largest, and then that's the way we will proceed with this. So we add the last one also into the remove list, and next we look into all the IDs of all the other boxes, except the last one. We look at all the IDs of the boxes, and then we progressively look at select the boxes with the maximum overlap. Let's try to understand this whole concept with a figure. So let's say this is the largest box with x1, y1, x2, y2 as the starting and ending coordinates, or corner coordinates, and this sx1 and sxy1 and Sx2 and Sy2 are those coordinates of the smaller box. So now this is the overlap area. Now what we are saying is, if this overlap is greater than a certain threshold, we will not take this box. Okay, if it is less than only then we take this box. Okay, so let's consider what we need to do. So your x coordinates increases from 0 to 250 this way, and your y coordinate increases this way. So the first concept is to take, to find the points where the overlap starts. Now if you look at this from the x coordinate perspective, the point where, if you compare this of the starting x and y x coordinates of the largest box and starting x coordinate of the smallest box, the x coordinate which is the maximum between this is where your overlap starts. So this is the maximum point. So x1 y1 is the maximum, because this has the maximum distance from here than this. So this is the point where, so what we do is we take the point with the maximum x1 as the starting point of the interface, which is this point. Okay, let's say this point, and then similarly for the y coordinate also, the point with the maximum, from 0 to from here it starts from 0 to this sy1, and here it is 0 to y1. So your interface, your overlap starts here. So this point is you take the maximum of this y, starting y, okay, as the start point. Next is to find this point. Okay, so here what we do is we take the minimum of this point, because so in terms of sx2 and this x2, the minimum is where the overlap ends. Minimum of this x is where the overlap ends, because if you compare, this is the minimum point. So let's say this is 200 and this should be around 210, let's say. So we take the minimum, which is where the overlap ends. And similarly, from the y coordinate perspective, again this is the minimum point where the overlap ends. So there you will get this. So you get the starting and the ending of the overlap area in this way. So let's see how that is done in the code. So this is the overall concept of finding these overlap areas. So let's look at the code to do that. So we are iterating through each of those IDs, and then here we are taking the starting x1, as I said, the maximum of between the big box and the ID which we want to consider, and the maximum for the starting y, and minimum minimum of x is the ending of the x coordinate, and minimum of both these things is the ending of the y coordinate. And so we calculate the area of this bounding boxes of the overlap area. We calculate this is the overlap area, the area of the overlapping portion between the big box and the smaller box. And then we take a ratio between the overlap area and the other area. Okay, and if the overlap ratio is greater than a threshold, so we have fixed the threshold by as 0.5, then we remove it. So if it is much larger overlap, we remove it. If it's much more smaller, you can alter this 0.5 and find this. And then once the non-maxima suppression the loop continues, you keep on removing each of those bounding boxes. You keep on eliminating those bounding boxes. We keep on eliminating till there are no more boxes to compare. So that's when you break the whole loop. And then we just arrange all those boxes into a list. Since now the make all these boxes into a list, and then finally you convert it into an array and then return it. So that's the whole function is all about. And then this is how we get it. So the selected will give you maximum selected will give you the eliminated or the bounding boxes where the minimal number of bounding boxes which cover the maximum area. So now we have seen that originally there were 19 boxes and now we have only 3 boxes. And let's plot these and then see how these things is. See, now you can see that the localization has happened to the area where the pothole is, and with minimal number of bounding boxes with covering maximum area. So that is what we have done this. Now there are some parameters which you can tune here, like the ratio here. If you just try varying these ratios or these thresholds and then see how many boxes gets listed there. So that's something which you can try out just to understand how much, what kind of threshold you need to adopt for your specific cases. So that's what you need to vary to get the maximum overlap between all those things. Okay, so that's the end of the non-maximal suppression. Now you can see that let's sum up what we have achieved so far. So far in this series we have done the data pre-processing. That is, we have taken both the positive classes and the negative classes, and we've done some augmentation methods to increase the number of this of the images through different augmentation methods, and then we extracted the features using hawk features, and the hawk features and the labels were converted into a HP5 data format, and then we use the data to build a classifier which we build using SVMs. And once the classifier were built, we got into the inference mode using the image pyramids and the sliding windows, and we got a lot of the overlapping bounding boxes, and finally we eliminated these bounding boxes using the non-maximal suppression. So this is this takes us to the end of our process, the building the object detector from scratch. Now and these are things which you should you try out, and then you have to change many of these parameters and see what changes goes into many of the results which you get, and that's something which is left to you to try out.